Hey everybody, wanted to go over a problem for ICE charts. So this is problem 5, and so let's get started. Now, in order to do this problem, notice it's asking us to write a balanced equation and include states. Well, in order to do this, we need to know how to draw or to write the formula bismuth 5 oxide. Well, bismuth is Bi. You can find that on the periodic table. And the 5 means that it's 5 plus. And then the oxide is 2 minus. That's oxygen. And so now what we want to do is find the least common multiple, which is 10. And so that means 2 times 5 is 10, and 5 times 2 is 10. And so that means that when we figure this out, bismuth 5 oxide is Bi2O5. Okay. Now, normally we wouldn't know what the formula or what a decomposition reaction actually produces. It could be a couple of things. It could be all sorts of different things. But in this case, the question tells us that it decomposes into its elements. So let's do this. Bi2O5. That's going to react to form, and its elements, Bi is not special, plus O2. And so we have to balance this, okay? Before we do, let's write states. What we know is oxygen is a gas, okay? It's diatomic gas. Bismuth is a solid, it's a metal, okay? And then Bi2O5, we don't know what that is, except it says right there. Also, bismuth is an ionic compound, so we have to assume that ionic compounds, for the most part, are going to be solids. Okay, so now we can balance this thing. So when we balance this thing, let me balance it in blue. So this is going to be a 2, but now we have 5 oxygens, and 2 times what gives us 5. So here we're going to want 2.5 oxygens. The problem with that is we can't have any sort of half, as our coefficient. So we have to take and multiply the whole reaction by 2. So we're going to have 2 Bi2O5 solid reacts to form 2 Bi solid. See, here I go. I do this all the time, and these are the kind of mistakes that ends up happening. Okay, that should be 4, because we had to multiply everything by 2. Okay, multiply all the coefficients by 2, plus 5O2 gas. Okay, so now that's the balanced chemical equation, and we have included states. But now it says determine how much of each product is made in moles. Well, here are the two products. In order to determine how much of each product is made in moles, and then subsequently in grams, we should probably do an ICE chart. So I'm going to do this. I'm going to do this. I'm going to go ICE. In the question, it says that we started with 86.3 grams of this. So I'm going to write 86.3 grams, because grams doesn't go in the ICE chart. An ICE chart is full of moles. Okay, the units of numbers in ICE charts are moles. So we have to take this grams and convert it to moles, and we are going to do that, let's see, by using the molar mass. So 86.3 grams of Bi2O5. And notice I'm not using the coefficient when I do this. The coefficient is for converting moles of one thing to moles of another thing, not for molar mass. So I'm going to take this and I'm going to get rid of grams. I'm going to convert to moles, but I actually need to calculate the molar mass here. So for bismuth, it's 2 times, I need to look up what it is. Bismuth here is 208.98. So that's cool. Okay, so that's times 208.98. And then oxygen, there's 5 oxygens, and oxygen weighs 15.9994. Okay, now we take that and we add that up. So we go my calculator turned off. So it's 2 times 208.98 plus 5 times 15.9994. We do that math, we get 497.957 grams per mole. Okay, carry it out to as many decimal places as you get. This is a constant, this is a constant, so when we add these up, we should get a molar mass that is constant. And so for every 1 mole, we get 497.957 grams, and we do 86.3 divided by 497.957. That equals 0.173 moles of Bi2O5. Now, notice here I have 3 significant figures, so I'm going to have 3 sig figs in my answer. So in here I'm going to do 0.173 moles. And now we can fill in some of the other boxes on the ICE chart. Okay, how much bismuth do we have to start with? Well, we don't have any. You know why? Because it doesn't tell us that we have any to start with. So that's cool. Okay, we have oxygen. We don't have any oxygen to start with. It doesn't tell us we have any oxygen to start with. And then the other thing that we can do is we can take this, and we know that this is going to continue to react until it's all gone. So we're going to go down to 0 here. So that means this must be minus 0.173 moles. This can tell us, and that's the neat thing, once we have this first change box, it can tell us the values in all the other change boxes. So let's take this now, because we knew that this has to go down to 0. Let's take how much this is going to change by, that's the C, and since this is going to change by some amount, it's also going to change, this is also going to add here. So let's use this value to calculate this and this. Okay, and we do that when we're moving across, when we're trying to find values across from each other on the ICE chart. We use the balanced chemical equation. Okay, so we have, separate that calculation, 0.173 moles of Bi2O5 X line, and this is going to be moles, it's going to be Bi2O5, and we're going to convert that to bismuth. Okay, and what I know is the balanced chemical equation says for every 2 of these, we have 4 of those. Now, if you can do this math in your head, bless you for it. Okay, that's fine, but I'm going to show how to do it. So it's 0.173 times 4 divided by 2. Some of you may recognize that this reduces to 2, and so then you just multiply that by 2, so you get 0.346 moles of Bi. That can go here, 0.346 moles. And because this is a product, we're making it so it's a positive value. Now we can do the same thing for oxygen. Very similar sort of calculation. So we have 0.173, I'm going to extend the page a little bit, moles of Bi2O5 X line. And again, we're getting rid of bismuth oxide, bismuth 5 oxide, but instead of going to bismuth, we want to go to oxygen. And so we use the balanced chemical equation, the coefficients. So there was 2 of these, and for every 2 of those, we're going to make 5 of those. Okay, so this one's a little more tricky, probably not something you can do in your head, but if you can, again, God bless you for it. You can feel free to write your answer directly. Okay, but then you divide it and you go, and so this is 0.433 moles of O2. So I'm going to write up here 0.433 moles of O2, and because it's a product, we are adding it. So now 0 plus this gives us 0.346 moles. 0 plus this is 0.433 moles. And so that tells us how many moles we have at the end. But now we need to convert to grams. And in order to convert to grams, we need the molar mass of bismuth, molar mass of oxygen gas. Okay, good thing we looked this up previous. So this is, bismuth is 208.98. Oxygen gas is O2, so that's going to be 2 times 16 is 32. But I'll go down here. Okay, so we want grams of bismuth. So we have 0.346 moles of bismuth, and we're going to X-line that, and we're going to get rid of moles, and we're going to convert that to grams. Every 1 mole equals 208.98 grams. Okay, so 0.346 times 208.98. Okay, and this is 72.3 grams. Okay, 3 significant figures, so it's 72.3. Now, just to make sure I don't get confused, I'm going to write this in green, so it's 72.3 grams. I'm going to put grams as my unit there. I do a similar calculation for oxygen. It's 0.346 moles. Oh, I'm sorry. How many moles of oxygen do we have? Not 0.346. We have 0.433 moles of O2. We're going to X-line this, and for every 1 mole, it's 32 grams of oxygen. So we're going to go 0.433 times 32, and we get this equal to 13.9 grams of O2. So now I'm going to put this up here, 13.9 grams. And again, I'm going to put it in a different color just to keep it separate. 13.9 grams of O2. So that tells us whether that tells us the right answer. It tells us the answer to part C. Now I'm going to double check this. In order to double check this, I'm going to use the law of conservation of matter. The law of conservation of matter says matter cannot be created nor destroyed in a chemical process. So we're starting with 86.3 grams. If we add up however many grams at the beginning, we have 86.3. Now, if we add up however many grams we have at the end, let's see, 72.3 plus 13.9, and so we get 86. This is 86.2 grams. And that, to me, checks out. Okay, it's going to be very rare that if you do something wrong, those are coincidentally going to equal each other. Okay, so there is the answer to this problem, and have a great day.